Hello and welcome to this part of C programming tutorial. In this part we will learn about variables and values in C. To begin with, we will see what is a character set. A character set is a set of characters which are allowed in that programming language here that is listed for C. This includes all alphabets, digits, that is the decimal digits, and various symbols of a keyboard except at the rate and dollar on a US PC104 keyboard. However, you can use at the rate and dollar symbol as a character, that is value of a character, and also in strings. These are keywords, and when I say these are keywords, that means you cannot have function name with that name, or you cannot have variable name with that name, sort of that thing. We'll see more about these, and you will actually come to know where these keywords are used. But of course, these can be part of strings. Now, the core of today's tutorial is what is a variable. In algebra, you might have studied a variable is something uh, whose value changes. So in our situation, the values are in memory, and then we need some to uh, name to address those memory with. So we say x is equal to 5. So 5 may get stored at some memory location which would be like 0x1, 2, 3, 4, 5, 6 and so on. But those memory addresses are difficult to remember for us, so we easily say x. So that's the mechanism of variable. Now there are several types of variables. The simple ones are primitive variables. They're called primitive variables because they store simple stuff. Three are of integral type: characters, integers, and booleans. Two are real numbers: float and double. Float is single precision, double is double precision. Char is basically used to store characters, but fundamentally they are integral, so you can do operations like addition, subtraction on characters. Pointers, arrays, structures, and unions are other types using which you can construct various complex structures. You can have pointer to integer, array of floats, a structure containing character, integer, float, or other pointers and arrays and unions. So various combinations are possible. We will see how to manipulate all of these later, I mean the complex ones. For now, we will restrict our discussion to simple ones. Long and short are modifiers which control the length. So an integer is typically 4 bytes, but when you say short int, that is guaranteed to be 2 bytes. Int may also be 2 bytes, but that is on rare systems like 16-bit compilers will have 2-byte integers. Long integer will be 8 bytes. So you see how these modifiers actually affect the length or the memory requirement of that particular type. There is another modifier called static. So you see static is a keyword here, and then we have um, int is a keyword. So these special words are keywords. When we go further, we'll see we have special syntax colors for these. So when we mark some variable static, that means only one copy of that variable can exist. So the value persists across function calls. And we'll see this when we deal with function calls and stack frames. Then we have two modifiers which control the behavior in terms of modification: const and volatile. When you apply const to any variable, then you can't modify its value. But if you have something like volatile variable, then the value can be modified other than something which belongs to program. We can also have const volatile, which means the variable can be modified by something other than program, but not the program. So it's confusing for beginners, but you will get hang of this in due course. Then we have signed and unsigned modifiers. So I'll explain this with an example. So a character is uh, basically 1 byte, that is 8 bit. So you can store 256 distinct values. Therefore, unsigned characters will have a range from 0 to 255. But signed characters will have a range from -128 to 127. Still 256 values, but range is split. One half is positive, another is negative. Now, since we have variables, we need to give them names. There are rules. They can contain letters, digits, and underscores. But names can begin only with letters and underscore. In a library, functions typically use names beginning with underscore. Therefore, you should avoid such names. Now, last thing is that if the variable name is counter, say our variable name is counter, then ampersand counter is its address. I mean the plain variable. Pointers have different mechanisms for this. Now, why are we even discussing this? Is because certain functions need address of function, because when you want to modify value of a variable which is being passed to you, then you need its address. Otherwise, you will get a copy, and the modification will not reflect when the function call goes back. But don't worry about that. We will see that in due course of time. So we have here integer I, which is uninitialized. So it will pick a value from stack. And then we have a character C initialized to small a and a float f, and a long integer LD initialized to this. And so we print that. So D %D is called format specifier for decimal, C for character, F for float, and long decimal. So it prints that, but garbage value will be printed for I from stack. And then we set I is equal to 9, so 9 will be printed here. And then we say short int si. Now this is signed, so you have got 2 to the power 15 minus 1, that is half of 65,536. So and this will be actually rounded off. Now if you say unsigned short, so this will be printed, but if you add +1 to this, then it will become 0. Now since C is a character which is fundamentally integral, so if we add it to 1, we get the next direct character B. Now you can see why we got B by referring to ASCII table. Now we have some function called putC, which prints this C to std out, which is our monitor. And if you want to get the addresses, you got %p for printing that. If you want to see how much memory they occupy, then you need to use size of operator, and you will see how much size that occupied. Now size of operator returns in terms of LUD, that is long unsigned integer. So let's have a look at the output. So we have this here. So if I say make IO, it is already made. Oops, make vars. So vars is made, and then we run it. So see, you got a garbage value here, and then you see floats have 6 precision points, that is 6 digits it will take. And then you see how 50,000 is rotated, so 50,000 plus 15,536 will be 65,536, which will constitute the entire range of short integer, that is 2 bytes or 16 bits. And then you see unsigned, and then these are addresses. So and then you have got okay, so yeah, size. So I think LU was the one. LUD is not required, so there was a mistake. So fix this. So now we make it again. So now we have this. Now 4148. Now notice here, these addresses, these 4 addresses are actually multiple of these. This is called alignment requirement. And for floating point specification, I request you to read the specification of floating point. This is just the beginning. The best would be you experiment with these values, you assign something, and you try to see how it works out, what is the range. And there is a header called limits.h. I'll show you that. So that will show you the limits of the environment. So you see, so here all the limits are mentioned, but it seems all are not mentioned here. So so let me try another one. I've got 2 compilers installed. Let's see. Okay. So we have GCC 40, C++, and then we have C limits. Okay. So this is also not there. On Linux, these are in limits.h. Let me see if it is here. It is not here. Limits.h is not here. So I request you to refer to limits.h on your system. It should be there. Or you can hop on to libreprogramming.org where you can find it in the header. Limits.h typically mentions the range. As you can see, this header actually so it takes me back to the same one. It is not written here. No, this is not the one in which we are interested. No, not even this. I'll show you limits.h in next part, that from where to deduce ranges of these values. In my book, it is mentioned in a table, so you can probably have a look at that. So do experiment, and in the next part we'll see the input-output functionality of printf and scanf mostly, how to format our stuff, how to get input, and so on. Thanks for watching the video.